let's take a look at what it means to solve algebraically for a root of a function. We know that the root is where it crosses the x-intercept. And notice on the graph, if I have a graph, all these points right here, what is my value for y? I know that my value of x is -1, -2, -3, but it's -3 and my y value is 0. At this point, I have -1, 0, and at this point here, I have 3, 0. So I can notice a pattern here. I notice that all my y values on my roots are 0. So now we're going to apply that same logic algebraically. If I know that my y value is 0 and it's going to give me the root, that's exactly what I'm going to do up here. So I'm going to substitute in for my output 0, and I'm going to solve this algebraically to find my root. So I subtract 6 on both sides, additive inverse. I get -6 equals 1/2 x. To get x by itself, I use the multiplicative inverse. So I'm going to multiply both sides by 2/1. And I get -12 equals x. I apply the symmetric property to get x equals -12. And that's my answer. I have one solution to this example, and x equals -12. So where does it cross the x-axis? It crosses it at -12. Let's try one more. Let's say I have 2x minus 8. Same logic. I know that my 0 is going to be, my y is going to be 0, so I plug in 0 for y, and I solve for x, so I add 8 to both sides, additive inverse. I get x equals 2x. T, put your chair down. And then I divide both sides by 2, and I get x equals 4. So there is one solution to this equation.